The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon. Thanks for joining us for today's webinar, a new approach to the Humble PIR. My name's Jeff Rushton and I'm the Chief Technical Officer here at Alarm Corp. For those of you that haven't been with us before, I might just run through a bit of housekeeping before we get started. You'll notice at the moment that you're muted, and you will remain muted for the duration of this webinar. And also, just to ensure that you can both see my presentation and hear me, if you wouldn't mind clicking the hand icon, just so I can make sure that I'm visible to you. Excellent. Thanks very much. At any stage that you like, you can, if you want to ask a question, please do so, but please type it in the little area down the bottom, and then please hit the send key. And at the end of the webinar, we'll run through those questions that you may have and hopefully try and answer those for you. So we'll get started. The topic, I guess, is a little bit obscure. Really, it's regarding a new range of Siemens magic detectors that have come out. But on running through the topic first, I figured that it was probably a good idea to, in order to understand where we are now, is to go back and have a look at the history of the PIR and motion detectors in general, just so we can see where we've come from and where we currently are. As you can see that the motion sensor, PIR, microwave ultrasonic, has been around for the last, I suppose, 40 odd years. And I suppose for those of you that have been in the industry since the 70s or 80s, like myself, I certainly know there's a few old timers here on the webinar today. It may be a little bit of a stroll down memory lane, ultimately. Back in the 70s, certainly the early 70s, ultrasonic detectors were released, and there was a few types around, like the Aerotech unit that's pictured up the top here. The biggest problem with ultrasonic detectors back then was that pretty much any air movement at all would generate an alarm. Shortly after the ultrasonic came out, I'm going to call it the good old trusty microwave was released. But it too had very much the same problems as the ultrasonic, but now it had a few more problems. The microwave could see beyond walls and windows, so it alarmed at anything like, I don't know, a tree moving outside or rain down a drain pipe. In the early 80s, the first PIRs pretty much came out on the scene, and they were very much a vast improvement over the microwave and ultrasonic, but they introduced new problems as well, like now problems like sun and heat were an issue that wasn't previously an issue with the ultrasonic or the microwave. It wasn't too long before some smart person thought we could reduce the problems by combining each of these detection capabilities and bringing out dual technology sensors. When these came out, sort of the idea was that it would finally solve the false alarm problem and provide a stable detector. That was sort of okay in theory. Combining detectors did make detection more stable, but it was certainly by no means without its own issues. Today, some 40 or so years on, the quality of pretty much all of the mainstream professional detectors has certainly come a very long way. The initial technologies remain much unchanged in terms of ultrasonic, microwave and PIR, but the background processing and the analytics now are far superior than what we had 30, 40 years ago. And that's mainly due to, changes in technology of chips and faster processors. So now they can do a whole lot more than they previously could. The trouble with today, if there is a trouble today, is that various manufacturers have their own keywords or their own key technologies. And some of those, in fact, some of those are the ones that we sell, like SwissTech, MatchTech, Blueline, Vector Enhanced, Dualtech, 4D signal processing. The list goes sort of on and on. It's probably a little bit harder these days to compare apples with apples because these particular technologies are only used within a particular manufacturer. But if we go through and try and just concentrate or focus our attention at the moment just on the passive infrared side of things, we'll go through and see how that has changed and how these new detectors that we have revolutionize that again. For a passive infrared detector, and I'll read the next couple of slides, infrared radiation, or IR, is heat. Any object with a temperature above absolute zero emits IR. IR is also a form of electromagnetic radiation, and it's transmitted at the speed of light. On the electromagnetic spectrum, it's located just past visible light. All the objects that we have in a room, chairs, books, people, they all emit IR, even if it's cold. We can sense high levels of IR on our skin, and for instance, even long after the coals of a campfire have stopped glowing, we can feel the IR energy by placing our hand over the coals. Our skin temperature in general does vary, but it's typically around the 32-degree C mark. And under normal conditions, when a person's skin is covered with clothing, the clothing is heated from within and it radiates into the room, a higher level of IR corresponding to its higher temperature. So the way that a PIR detector works is it detects the changes in the amount of IR energy received from an object, i.e. a person moving in a room, at one temperature against the background temperature. There are four basic elements of a PIR. One is the optics, whether it's mirror or Fresnel lens, the sensor, typically called an IR sensor, the amplifier circuit behind it, and the logic then to generate an alarm condition. I'm going to concentrate in the next few slides, in particular with the way the optics of a passive infrared sensor work. The purpose of the optics is to gather as much IR radiation from specific spots in a room and focus that energy on the sensor. The optics have generally got a number of optical elements and they're aimed in different directions. And we'll see this in coming slides, visual diagrams of how this works. Each optical element produces a distinct detection segment, and this is done to create as much radiation change as possible as the intruder passes into or out of a detection segment. There's two basic types of optics that you'll see on a PIR. One is called a reflective type, which is mirror optics, and the other is refractive, which is a Fresnel lens. Both of these are used in PIRs. However, the focusing characteristics of mirrors permit large, efficient optics to be concealed inside a relatively small housing. The mirror optics are considered high gain, and they're designed to produce strong, sharp intruder signals, thus reducing the sensitivity of the electronics, and this is a major factor in false alarm reduction. since high-gain optics will not amplify radio frequency, interference, or electrical noise. If we have a look at the heart of a detector, which is the IR sensor, that picture is typical of a sensor on a passive infrared detector. And the purpose of this is that it converts IR energy into electrical energy. So normally this device is, they call it a pyroelectric sensor. The name pertains to the material property of the device, and it produces electrical energy. And then your circuits and whatever can determine the level of energy and then determine the type of alarm that it should generate. If we have a look at a typical Fresnel lens detector, I'll move my mouse around up the top here, hopefully, so you can see that a typical detector has its base with the PCB and electronics mounted in the base, the terminal strip also on the base unit, and the sensor is located somewhere in the middle there. The detector case is just a bit of plastic, and the mirror in here is not a mirror, it's a Fresnel lens. That lens is smooth on the outside and corrugated in order to reflect the outside infrared energy directly on to the sensor of the detector. And in a nutshell, that's how a Fresnel lens detector operates. If we have a quick look as a comparison to a mirror optics detector, you can see here that the design firstly is totally different in the sense that on the base, the only thing that's located there is a terminal block where your cabling is terminated. On the unit itself, we notice we've got our PCB, we have our mirror optics lens, and on the other side of that there is the IR sensor. And if we have a look at it from the front, it still has an IR window, which is the opening here, but that isn't the bit that's doing the detecting. It's the mirror on this black mirror that's on this unit. If we have a better look now at a diagram on the next slide, we'll see exactly how that works. So on the left-hand drawing, we've got your standard Fresnel lens unit with our lens or IR sensor mounted on the back, and it's looking out. We'll just say that there's 3 zones at the moment. There's typically a lot more, but there is a far, a medium, and a near zone. When we compare that with the mirror optics on the right-hand side, we can see that our IR sensor is actually facing in the opposite direction, and it's looking directly at this mirror. And it gives us still our far, medium, and near zone. But now with the angles, we can get a direct look down zone. So now we can get coverage directly under the PIR. If we take this a little bit further, we'll have a look at the advantages, and then I'll show you how that works in practice. A few of the advantages of a mirror optics unit, and we'll see this in coming slides, is the focal length is adjusted for each zone independently. So basically it's saying all these zones are properly in focus, and what that results in is uniform sensitivity across the entire coverage area. Another advantage is we do get a look down zone. A key advantage is that the lens or the IR sensor now is protected inside the detector, so there's much less likelihood of it being damaged or vandalized. There's very low transmission losses through the white light filter and very low reflective losses at the mirror. So basically you're getting more signal through, so it's more sensitive, but less false alarms. And any distortion or problems with the front filter will not affect either the zone sensitivity or the focal length. So even without the front IR filter, it will continue to work. Some of the advantage of a Fresnel lens is it's cheap to develop and it's very cheap to produce. Some of the disadvantages of mirror optics is it costs a little bit more to produce and costs a little bit more to develop. But there's a lot of negatives with a Fresnel lens. Almost all of the fixed focal length for the zones, they're not all in focus, so there's no uniformity of sensitivity whether you're close or whether you're further away. You don't get a look down zone, so you get less coverage. The lens isn't protected in the detector, so vandalism or breaking the front element, you could do that by a pen or a dart or poking your finger through, could not only stop the unit from working but damage the unit as well. There are some transmission losses from the filter, so therefore it's less sensitive. Then therefore it's more prone to false alarm because there's more noise induced as well. And as I've said, any distortion of the front lens by physical damage or potentially by sunlight or by age, if it starts cracking, it will affect both the zone location and the sensitivity, and potentially it may just stop working altogether. So if we have a look at a typical mirror optics detector, the picture on the left is showing a side-on view. So we can see that we have full coverage under the detector and full coverage for the length of the particular detector, in this case 12 meters. If we have a look at the drop-down coverage on that same detector, we can see that it's got like a 90-degree coverage. It goes out 10 meters each side, and it too has got a complete detection coverage. There's no dead spots in that graph at all. If we have a closer look on how the mirror optic detector works, we can see that on the left there's that IR window, which is a bit of plastic on the front of the detector, our mirror, and our IR sensor, which is at the top of the mirror. If we have a look at sunlight, sunlight is the natural enemy of the passive infrared sensor. So a lot of the sunlight is reflected from the IR window, in our case. A great deal of the rest of that sunlight is actually absorbed into the mirror. All of our slides here show a black mirror. That was one of Siemens' I suppose, typical traits of all of their PIRs, as they were all mirror optics and they all had a black mirror. The idea of a black mirror is, of course, that black absorbs both heat and light. So more of that is absorbed and less goes or can be directed onto the IR sensor itself. The same with heat sources. Some of it is reflected off the front plastic, and a great deal of the rest of it is absorbed into the body of the mirror, where the infrared energy of a person goes through the IR window at the front and then gets reflected onto the pyro sensor at the top. So it's sort of a graphical representation on how that mirror optics works. One of the other important features when we spoke about mirror optics was the fact that we said that it had a uniform sensitivity across the full range of the device. The best way, I guess, to show that or to describe that is to think of it like a zoom lens on a camera, in the sense that your close zone at the top is giving a relatively wide angle, so you're getting a wide angle shot. As we go down the various gradients of this mirror, its zoom lens effect is changing. That is, it's bringing objects that are further away now closer. So to the IR element or IR sensor, it's looking the same. And we'll see that on the next slide. So we can see here again, on the left, an object that's closer to the detector looks larger. So both you have no idea whether that's a rat or a cat, and the person appear larger when they're closer to the detector, and are smaller, or certainly less sensitive, the further that they get away from the detector. With the mirror optics on the right, you can see that whether they're close to the sensor or further away, their relative size to the detector is the same. So the sensitivity level will be the same, regardless of whether they're a couple of meters in front or, in our case on this detector, 10 or 12 meters away from the detector itself. So just a brief summary on technology, I suppose, as it is today, is that mirror optic detectors are definitely superior to a Fresnel lens detector, basically because we get improved and reliable sensitivity and performance. I haven't mentioned this, but ease of installation. The fact that the electronics are mounted on the detector and not on the base means that it's very easy now to install the base on a wall, to pre-wire it onto the terminal block, and then all your delicate electronics and sensors and mirrors are on the head of the detector, which is the last thing that's put on. It also makes it easy then to pre-wire a job where you want to put the base and wire it up, but you can't complete the installation until, I don't know, the final coat of paint is done, or until after the building is finished, and then you're allowed back in to finish off. So it makes it very easy to install, or potentially to replace a faulty sensor if that occurs in the future. We have improved reliability, since the damage to the infrared filter won't affect the performance of the detector. We get our look-down zone. And we also get superior dust and insect protection from ingress to the IR sensor itself. These detectors are pretty much sealed, as opposed to a Fresnel lens, which is relatively open, and dust and insects have got a habit of migrating to the warmth and to the frequency. When you're purchasing a PIR, maybe questions to ask to yourself or to your distributor or to your customer is it mirror optics? Does it have a thing called a continuous self-test? Most detectors these days, that when you power them up for the first time, will test its circuitry and test itself and come up and tell you that it's okay. That's all well and good, but wouldn't it be nice that if in 3 years down the track that the detector decided to stop working, that it would come up and tell you? A good detector will. To have remote control over the alarm LED is also, in my opinion, an important consideration, and all of the sensors that we sell have this function. That, typically, unless it's in a residential use, detectors are mounted in a public open area. If you're a criminal and you see the detector and you can see the LED come on and you can determine where its range is, where it stops, where it starts, where there's potentially no coverage, that you might be able to work out a way of getting around it. Ideally, in a public area, that you want that during the day, when the alarm system is turned off and the detectors are still powered up, that you typically would like the LED not to work. So therefore it gives no indication to anyone in that public space as to whether the detector is working or in fact the range that that detector has. These days every detector, or every detector should have DSP. They should have a digital signal processing. If it doesn't, I would certainly avoid it. And ideally the selection of having a couple of different lenses that maybe go from wide angle to long range to curtain coverage are all good things to have. And all these relate to security detectors. If it was for some other purpose, ringing a doorbell or opening a door, then maybe these things aren't absolute requirements for it. But for a security sensor, I think they are the basic standards or requirements. So that brings us on to, it's a weird name, but the Magic motion detectors. This is the new range of detectors from Siemens, and that's one of the ranges of passive infrared sensors or detectors in general that we sell. Maybe this isn't the best picture to show you, but one of the, or a few of the key features, but certainly the most obvious feature that no other detector on the market has, is the front face of this detector is totally flat. There is no protrusions at all. The detector, the lens, it's flat. So this is like a little rectangular block. It's flat on all sides and it's extremely thin. So to start with, to look with, it's striking. It's different to any other detector on the market. How is it possible to have a flat face detector and still have the coverage that we require, including a look down zone? Well, guess what? They've taken the process of a mirror a little bit further and now have added a second mirror to their mirror optics detectors. So if we look at the picture on the right hand side, we can see the sensor now is, actually I might move my mouse over a little bit. The sensor now is actually facing towards the front, but it's in a hidden, concealed area at the top. And it looks initially at this second mirror, reflects off the first mirror, and then will go out to give its zone coverage. The same process with its undercrawl zone is that second mirror now allows enough angle to have a zone which basically goes directly under the sensor. With that second mirror, we now get a much better degree of sensitivity and focal length on the longer zone. So now it's far more reliable for objects further away than pretty much any sensor that's gone before it. So our double mirror leads to our longer focal length, which gives better imaging of a far away zone. It has got sensitivity across its entire detection range. Some models of this have anti-mask, and the anti-mask is actually integrated into that second mirror at the top. So it's completely concealed and forms complete protection of the detector window. And it allows the detector to be extremely thin and, as we've said, totally flat on the front. As I've mentioned, Siemens have had black mirror technology for many years, and it's a thing that normally comes up on all of their data sheets. The thing with the black coating is it led to greater white light immunity because the black absorbed the light or a lot of the heat. As you notice, the Magic mirror is no longer black. It's just standard shiny, mirrory sort of silvery finish. Why is that? It's now because that with the introduction of that second mirror, by having now a multiple white light filter in front of the sensor element, you now get the best possible form of immunity and the highest level of false alarm immunity. So we no longer need to keep that black. We've got the fact that it needs to reflect off one mirror onto another, then onto the sensor, gives it an extremely good white light immunity. And we've got here a uniform design. You'll see in the next couple of slides that there are only two cases for all of the sensors, so they all look very much the same. So on this slide here, we can see the detector located on the wall. It's, like most detectors these days, it's pretty unobtrusive. This has a very modern design. To me, it sort of fits into any environment. As we've said, it has a flat face, and it is extremely thin. So what Siemens have done is have the ability, and I suppose this could be available on any detector, but they've added a couple of accessories which really complement the style of this particular sensor. This particular one comes up very good on my monitor, but it may not on yours, is there's an option for a base plate that basically has a metallized or a mirror finish. And what that does is reflects the color and the structure of the wall that it's mounted on. So now it takes on a more invisible look. It fits in, it blends in to a variety of walls. It says it's perfect for non-white. It's just as perfect on white walls. But now if you've got a different color or a different finish on a wall, sticking this detector with this metal base just allows to reflect the structure of that wall from the detector. So it blends in. The only thing that looks different is the front face of the unit. That option is available for all of the 12-meter versions of the Magic PIR. Certainly one of the absolute unique features is the fact that we've got now a completely flat face lends it very well to having a flush mount kit. So now we can have complete integration of the detector into a wall. So there's minimal visibility. There's no other detector on the market that is totally flat and can be flush mounted. The level of security is unchanged. It still has its look down zone. It still has its normal range. And this too is an option for all of the 12-meter detectors. So if we go back and have a look at our detector on the wall and then replace that with our flush mount unit, you can see that it very much fits in and doesn't look out of place at all. As I've said, this detector only comes in two housings. There is a smaller housing for the 12-meter models and a slightly larger housing for the 18-meter models. There are 4 detectors in each of the ranges. You can have PIR by itself, PIR and anti-mask, PIR and microwave, or PIR, microwave and anti-mask. And that's for both the 12-meter and 18-meter units. Regardless of whether you get the 12-meter PIR or the 12-meter PIR microwave and anti-mask, they all look the same. So as it says down here, the intruder must anticipate the highest security level because they don't know. You can't tell the difference between the detectors. So it makes it very easy to mix and match 12-meter detectors on the same site, and they all look exactly the same. If we have a look at some of the other advantages of these Magic sensors, if we have a look at the terminal block on the right, it doesn't need to hold any of the end-of-line resistors anymore. All of the resistors can be installed directly on the back of the detector, like in the second drawing, or you can buy an optional resistor pack for a variety of different panels, so it means you no longer have to install or configure your resistors. Just wire your power and your circuit and you're ready to go. So it makes it for a much cleaner and a much simpler installation. If we show you how the resistors work, we'll have a bigger drawing here. It comes with a little template on the back of the sensor that you can put your resistor on and then cut it to the right length. And then once you've done that, install it. In this case, this is a fault resistor and is installed on the two little pins that are on the top of the detector. And then you fold it down and you're done. So a much cleaner installation of resistor installation than as previously been done on any of the detectors that we have. And then you're complete. The other thing that I suppose is more important these days as well, or becoming more important, is the energy efficiency or the green rating of electronic products. These detectors have an extremely low current draw. As you can see, the standard 12 meter or even the 18 meter PIR only draw 2.5 milliamps in their normal state. So that is extremely low for a passive infrared detector. So they're very energy efficient, so therefore you need smaller power supplies and smaller batteries in order for them to continue lasting. Other accessories that you can buy with these detectors is there is a combined wall and ceiling mount bracket, which is the picture on the left. It conceals the cabling and it allows for full adjustment of the detector. So that one bracket is good for mounting on a ceiling or directly on a wall. There is also what they call a 1/4 inch adapter, which can be mounted on the back of a detector. And what that does is allow you to use any standard CCTV camera bracket that you wish. They all have a 1/4 inch thread, and now any existing CCTV bracket could also be used as a mounting bracket for this detector. Probably not overly common, but I'm sure there are some people out there that standardize on a particular style of bracket, and in this case your PIR now can work with that as well. We can add a small pet clip, which is that little bit of black plastic on the right hand side, and now it turns your detector for the 12 meter detector into a pet immune sensor for a pet up to about 20 kilos in weight. So just by adding that little bit of plastic, we can now have full pet immunity. So ideal for residential situations. So the full range of accessories on this product are you can buy a curtain mirror set for the 12 meter, a curtain mirror set for the 18 meter detector, our mounting bracket that we just saw, our 1/4 inch adapter that we saw as well, our pet clip, and we have the option for a flush mount or a metal base or a metal looking base for our 12 meter sensor. And the last accessory that you can purchase for these is if you don't want to put those resistors in individually in the back of the sensor for your end of lines, you can buy a little end of line board. It accommodates a lot of different panel types and a lot of different resistor types. For any that aren't listed, they can be easily made up and provided. They come in bags of 100 and just insert straight into the terminal on the terminal block on the detector itself, and your end-of-line resistors are now taken care of. So in summary, for these new Siemens Magic detectors, they're available now. They do replace pretty much all the existing Siemens range of detectors. They have an unrivaled detection performance through the use of the Magic dual mirror technology. They've got certainly a very modern and we would say an elegant design for the units. Can be flush mounted. There's certainly going to be some applications where flush mounting would be an absolute bonus to have. As we've said, all of our detectors only come in 2 housings, so they all look exactly the same. They're very energy efficient, and they're extremely easy to install. So in summary with this, our Magic PIR detectors, less is much more. Whenever you see any of the advertising for this product, or go to the website, which will show up next, is this logo will be very prevalent throughout. So there'll be a bit of a campaign for these detectors, so you'll see a whole lot more of this little red guy in the big blue pants. So if you would like to know more, our website's certainly a great place to go. Currently you won't find any information on these new detectors, so there is a website, magic-detector.com, that will have the data sheets, some presentations, a lot more information than we've gone through in this presentation. And certainly if you want more information from Alarm Corp, please subscribe to our Alarm Corp Pulse. It's a newsletter that comes out once a month and it's emailed to you. You can register online at our website, and you can also, by registering, get full access to our e-commerce site and get pricing, and you can place orders there as well. If you want more information, please feel free to contact any of our staff listed there, or of course quite happily contact myself direct. We haven't been on Facebook, LinkedIn and Twitter for very long, but please, the next time you're on any of these social media sites, please just do a quick search for Alarm Corp and then either follow us or like us. We have quite regular feeds, certainly at least every day or every second day. It's different to the information that we have on our website or that we email out. It's a lot, I'll say it, a lot more friendlier, low-key, not necessarily on all of our product range, but on our general industry in general. So again, next time you're on any of those, just do a quick search for Alarm Corp and then like us. Very soon, on the 4th to the 6th of next month, Alarm Corp will be at Security 2014. For the first time in many years, it's down in Melbourne. So if you're aware of this, I'm sure that you're probably already planning on going or whatever. But certainly, if you're in Melbourne at that time, this expo is a good place to be. We're right adjacent to the front door in stand number I8, so very close to the main entry doors. We're going to have on display all of our SCEC approved products. We've got quite a swag of those now, so they'll all be shown. All of our Interlogics, NVR and camera products, our Verint Nextiva and their cameras, a range of Sony cameras, and the Ingersoll Rand readers, as well as our Siemens SIPAR system. So if you're around, please call in and at least say hello. And if you don't want to say hello, just drop your business card in for a chance to win an iPad that will be on our stand as well. Alarm Corp is conducting a lot of regular webinars for the remainder of the year. In fact, I should have said right at the beginning that this is our second webinar in 2 days and our 30th webinar in total. So we're racking up these numbers pretty quickly. So we've got quite a number of security webinars for the remainder of the year. They're typically on every Thursday, every third Thursday, except this one, which was on the second Thursday. Couldn't add up. And a bunch of CCTV webinars. If you want to register for any future webinar that we're holding, or certainly if you want to view any of the previous webinars that we've done, just log on to our website, click on resources at the top and then webinars, and you'll be able to register or see any of the previous webinars from there. By attending today, you do get special promotion that we don't advertise anywhere else. If you buy anything online during checkout, just type in that checkout code and you'll get an additional 10% off whatever your current price with us is. It doesn't include SIPAS Sony invariant products, but absolutely everything else you will get an additional discount on. Certainly now we've come up to questions. So if you have got any questions now or have typed them in during the webinar, please type them in now and I will go through and answer those for you. Okay, I'll just wait a few secs. Okay, someone's just asked, so you're saying to avoid Fresnel lens detectors. I guess that's pretty much the gist of what I've been going through. If it's for a security application, absolutely. I really don't believe they have a place in, these days anyway, as a security detector. And really what it comes down to is the real cost between one of those sensors or a mirror optics detector, you know, is in the dollars. So it's potentially maybe 10, at the most maybe $30 difference on a sensor. And I would always look at it in the way that, you know, what's the real cost of a service call during a warranty period? You know, it's obviously considerably more than the price difference between the cheap or the good sensor. So to me, it's really a no-brainer. You'd want to put in a better sensor that's more reliable, less false alarms, keeps your image looking a bit better, reduces your call-out rates, whether it be in warranty or out of warranty, and just a much smarter solution in my eyes. Someone's also come through dual technology sensors. Do you think dual technology sensors still have a place? Well, I suppose the fact that we have continued with a dual technology sensor even in this new range of sensors, I believe that the need for them is reducing. You know, 10 or 15 years ago, they were extremely commonplace. There are loads of people around that still use them, more to do with force of habit than anything else. But I definitely believe it's the need for them is reducing. I reckon a good standard detector is fine for just about all your normal applications, and a dual technology sensor really only needs to be considered in, let's say, a really harsh environment. Certainly more than that, anti-mask, which we really didn't, other than mentioning, I didn't really talk about. Anti-mask is probably the option that more and more people are asking for. Even though anti-mask has been around for a long time, it was only really ever used on higher security installations. We're sort of now more people asking for it for standard commercial jobs, and typically it's in the cases where they're more concerned with their staff, either, you know, tampering or trying to get around the security system in place. So, you know, in a nutshell, what anti-mask does is bring up an alarm if someone tries to either cover the detector or maybe spray it with something, you know, where they somehow try and put something in front of the detector to stop the detector from having any range. And so hence that's the reason why all of our detectors now have the option for anti-mask, because I believe that's becoming more and more prevalent. One more question here. I know you've been big in the educational sector with your detectors and have done for many years. Does this new detector have any new benefits? The short answer is yeah. Alarm Corp and with the Siemens detectors have been in sort of every New South Wales school for the last at least 20 years that I'm aware of. The new Magic detectors, they have all of the same benefits as all of our previous detectors, but now there's probably two main features additional to what has previously been around. One is the end-of-line resistor ability, so it just makes installation so much more easier. And I really do think the use of dual mirrors, which is the only detector I'm aware of that is using this functionality really should give increased reliability and increased sensitivity across the entire range of the unit. So I believe they will further enhance the reliability of the unit. One of the key features of, I suppose, mirror optics in general these days, but Siemens have had mirror optic detectors since, for many, many years, is one of the big benefits of that is if you try to sabotage or damage the front of the sensor by, typically in a school, or I suppose really any public place for that matter, where someone might throw a pen or a dart or something sharp and it pierces through the front lens of the detector. One of the biggest concerns is on any other sensor that could potentially either damage the IR sensor or the PCB, and then obviously potentially stop that detector from working. With these detectors, both the new and the old detectors, that sensor is totally hidden. So if you pierce the front of that detector, the worst you're going to do is scratch the mirror behind it, which will keep still the detector will operate, it will still have the same sensitivity, it will have the same range. So even though it might look damaged on the outside, it will continue working. I believe that with these new sensors, the sensor is even more hidden with the dual mirror, so I believe that it's even more sabotage proof than any of the previous sensors that we've had before. Next question. Do these detectors have tamper capabilities? All of the detectors that we have, and certainly all of the Siemens detectors, have got a tamper switch built in to the unit, and that tamper switch can operate a number of different ways. At its very minimal mode, if you remove the sensor off the base, the unit will go into alarm. And they all have the ability now that they have what's called a knockout tamper on the base. That is, if you put the detector on the wall and screw it in according to the instructions, that if you rip the detector off the wall, that tamper switch that's on the detector will also activate for when it's removed off a surface. So you've got the ability to tamper when the detector is moved off its base or when the entire detector is ripped off the wall. And if you use the anti-mask function, now will give you a tamper alarm if something is placed in front of the detector, or if you get a spray and spray over the lens of the detector to stop coverage, you will get an alarm from all of those activities. So I hope I've answered those questions okay. Certainly, if you go away and think of more, please you can email me anything that you're after, and I'll get that to you as soon as possible. I'll get that to you straight away. If there's no more questions, then like I always do, I'd like to thank you for attending our webinar, and we certainly do appreciate the time you've taken out of your schedule today, and we certainly hope you found it beneficial. We look forward to seeing you next time, so please enjoy the remainder of your day, and goodbye for now.